So here we are in NetBeans. And what I'd like to do today is take a look at creating a method that returns a value. Now the function I usually use in lots of different programming classes is a method for converting from Fahrenheit to Celsius. So we're going to create that right now. We'll call this a new project. And we're going to make it a Java application. So you want to put this in your H drive. For me, it's my Z drive, but so I'll call it that. You can call it what you like, but it kind of tells me what I'm trying to build. All right, so here's our main method, and we're not going to do anything with that right now. But we are going to create another class we'll call this the metric conversion lib. So the metric conversion library, this is the first step in a larger project. Eventually, we're going to create methods that convert between the metric system and the American system of weight and measures and back again. But we're going to try to build up this library so we can use it in other programs. That's what's cool about programming, is you can write code that you can use not just in this program, but lots of other ones by turning it into a library. So we'll do that. And this is a library that doesn't require any instance variables. We're going to pass in everything that we need into the parameters of the methods. So we want to add the keyword static right here. It's complaining why. For some reason it doesn't like that. I think we have to add some methods. Let's add our first method then. Public. So we're going from Fahrenheit to Celsius. And you would expect that in some of the conversions you're not going to end up with a whole number. So the return value of what we're going to get back from this function or this method is a double. Remember, a double has a decimal point and things to the right of the decimal point. And we can call this F2C. So what is this method going to need to translate from Fahrenheit to Celsius? Well, the data we need is actually the temperature in Fahrenheit. So that'll also be a double coming in. And then we'll give it a name like ftemp. How about that? Now we have a complaint coming back from the compiler saying, hey, there's no return statement. Notice that instead of void right here, we have the word double, which means we have to return a value. So we say return .0. And that should satisfy the compiler. Obviously, this isn't going to work, but I'm going to try to understand what they're trying to say. Modifier static not allowed here. Yeah, so we'll hold off on the static thing until I understand it. So that's the structure of the conversion. Yeah, here's the tester for it. So we can say this. We might call it ctemp. That's going to be our Celsius temperature. And we'll say ctemp dot metric conversion lib dot F2C, and we'll pass in ctemp as the parameter. And again, it complains, says this is a non-static member. So So in the library then, I don't think we can put static on the class, but we can put static on the method. And the keyword static is kind of weird. It comes from the C language. It doesn't really describe what it means. But in layman's terms, what static does is it says that you don't have to have an object of type metric conversion lab. You can just call this method by stating the class name. You don't need an object to be able to run this. So by making it static, if you look over here, the problem that we have goes away. So it says here that ctemp hasn't been initialized. That's just a warning. I guess that is an error. So you say ctemp, and we might set it equal to, well, what's the temperature we know? We know that passing in ctemp, so going from, I guess I named it wrong. I called it F to C, because we're going from Fahrenheit to Celsius, and we pass in the Fahrenheit temperature. So back here in the tester then, we'll change this to ftemp. And then we'll say we can say this. We can say, I want to take that ftemp, whatever the temperature is, and convert it into a ctemp. Here it's saying can't find symbol, so we need to declare that up here as well, ctemp. So that's good. Now let's set the Fahrenheit temperature to something we know in Celsius. We know that the boiling point of water is 100 in Celsius, and the freezing point of water is 0. So if we pass in 32, we know that that's the freezing point of water. What we expect to come out is 0. If we put in 212, we'd expect that this would return a value of 100. So let's add our output now. We've done our input. I guess that's our input. Here's our processing. Okay, here's our output. So we say system.out.println, and we're going to print out the Celsius temperature. So that's a string. That's going to just label our data, and then we'll print out the data, which is ctemp. Okay, so we have our two temperatures. We initialize one of them. We use that one to send into a method which returns a value in ctemp, and then we show the user the temperature. If we run it now, we'll note that it's not correct. So we ran it, and with 212 for Fahrenheit, we get 0. The reason for that is we haven't quite completed our equation here, F2C. So we still need to fill this in. We just put the 0, 0 in there earlier just to satisfy the compiler, but now it comes time for us to do the math. Well, where's the math? If you look out on the calendar, here's the assignment, and I think it gives you the equation here. So right there. So then the question is, how do we write that in Java? Here's the equation that was on the slide. First, there's the Fahrenheit temperature. So that's coming in as a parameter. So we can replace that then with ftemp. We subtract 32 from it. Now the order of operations for Java is it's going to do the multiplication first, so it's important to put in the parentheses there because you want this to happen before you multiply it. This will create, yeah, I'll just keep it simple. Now the way you do multiplication in Java is the asterisk, not the little X thing. Now our Celsius temperature is going to come out as the return value, so you don't actually have to say the equal sign. Okay? We're just going to do the equation and then spit it out the other end. Now I'm curious whether or not the compiler will understand this. So let's just try it and see what we got. You get 324. It's not right. So we subtract 32 from that, and then we multiply it times 9 and divide it by 5. So what would I do? I say, let's be a little bit more precise. So we're going to force the compiler to think in as doubles rather than integers. Okay, so we'll do that. So look at 324. Why would that be? So we're passing in. Does anyone see what I'm doing wrong here? Well, when you have a problem, you can't really figure it out. You go into the debugger. So I'm going to set a breakpoint, and we'll learn about the debugger shortly, but here I can run the program until we get right there. We can check our ftemp is 212. Yeah, so maybe this is upside down. It's supposed to be 5/9 maybe. So we take a step. That's here. And we're looking at ctemp. Where's ctemp? I guess it hasn't been created yet. Yeah, so it's upside down. So the slide was wrong. So even though it did the math correctly, it was the wrong function. So is that a runtime error or a compile time error? Or a logic error? Our problem was it was a logic error, right? And that's what a debugger helps you do, is it helps you figure out, okay, what's really going wrong here? So fix the equation, and we'll see if we get the right result now. Every time you run a program, you want to ask yourself what's going to come out the other end. What is your expectation? So you don't run it without having that in your mind. Okay. We're expecting to get 100. Let's see if we do. Yeah. So now that we have the correct equation, we get 100, which is pretty cool. So now in this library, we have this way of converting from Fahrenheit to Celsius. And our tester program allows us to do that. It would be more helpful if, instead of hard coding in a Fahrenheit temperature, we give the user the ability to specify which temperature they want to convert. So how would we do that? Okay, so basically what I'm saying is, you know how when we write our text, it writes it in the output window? Well, we can also get information from the output window as well. And then here we can just say input dot next. I don't see that one there though. Oh, I see. Yeah, we have to create the scanner first. So we're going to say scanner. It's not a great name. Console equals new scanner. And you have to pass in input into that. And this creates a scanner for us. We don't have the import for scanner quite yet. So scanner was just added to the language within the last couple of years. The old way of doing input was really clunky. You had to do like 3 different classes, and for beginning programmers it was a mess. This seems kind of clunky as well, but but it's a little bit simpler. And then here's our next functions finally. So we want to get the next double. So what that means is, okay, go out to the input stream and grab the next double you see. And then once we have that double, we'll pass that in and we'll be able to do the conversion. So let me just run it. I'll leave this up for a little while so we can try this. So it's waiting for us to type something in here. So if I type in 32 and hit enter, we get a Celsius temperature of 0. If I run it again, and I put in 212, these are the ones we know, I get 100. So now we've just turned this program that could only do, 212, because we were hard coding the Fahrenheit temperature to the boiling point of water. Now we've instrumented our class so that you can put whatever number you want in and it will do the conversion for you. So now this becomes a lot more functional. And how are we doing this? Because we have this method inside of our conversion class. And so now we can pretty much translate any temperature in Fahrenheit to any temperature in Celsius because we have this method available. And then how do we verify that that's correct? Well, we wrote a test class. Here's the main method. We asked the user to input what they want to convert. That's what this is all about. Here we want to put some comments in. This is a little bit weird, but create. So the console is this down here. See how it says debugger console? This is the output console. Create an input stream from the console. So we create our input stream using system.in, which is the console. And then once we have that, we send that into the constructor for a scanner. It needs to have an input stream. So we provide the input stream and the scanner gets that all set up for us. We call it console, just so that we know. Instead of hard coding this to 212, we now ask the console, what's the next double that's on the console line? It goes and grabs that and stores that in ftemp. Here's the assignment operator. Now we have the Fahrenheit temperature. We use that to pass into our static method. It spits out a result, which is our Celsius temperature. And then finally, we show that Celsius temperature to the user. Okay, so here's our input part. Now, every program you're ever going to write has 3 parts to it. It doesn't matter which language you write programs in. There's always 3 parts. There's the input part, there's the processing part, and then the output part. So it would be kind of silly if we took all this time to do the conversion, but then failed to show the user what the result was. So you're always going to need an output part. In this one, well, we need to transform the input into the output. So you've got to have some input. So that's a requirement of every program you're ever going to need. Now, if the input equals the output directly, then there's no need to have processing. But if they're the same, then there's no need to have the method itself or the program itself. So you need all 3 parts in every program you're ever going to write. So we get the input, we process it, convert it from Fahrenheit to Celsius, and then once we have that conversion, we send it out to the command line. So this is part 1 of our project. Now it might be nice up here at the top to kind of prompt the user what we're asking for, because right now all they're getting is a blank line with nothing there. You could say something nice like system.out.print. Notice I didn't say print line. Please enter a Is that right? I think so. My German's a little bit rusty. And you might put like a arrow or something. So you'll send that out to the output stream, and then the the user is going to know what it's asking for. Please enter a Fahrenheit temperature. So I click down there and I put in, how about 23? You get -5. That seems plausible. Okay. Maybe one more space here so it doesn't look so cramped. So by using system.out and system.in, we can make a pretty functional little test program. Okay, so now I'm going to bounce out to the calendar. If you look at the conversions then that we're going to supply in our little library. And again, don't put a main method in this class. Include the following conversions: inches to and from centimeters, feet to and from meters, kilometers to and from miles, ounces to and from grams, pound to kilogram, Fahrenheit to and from Celsius, miles per hour to and from kilometers per hour, and then gallon to and from liters. Create a test class that has a main method that tests each of these methods in the conversion class. So imagine you're an American, you're over in Europe, you're trying to figure out, okay, you're making a recipe or something, and everything's in the metric system, and all you know is cups and stuff. So you could use this class to help you convert weights and measures. Or if you're writing an online cookbook and you want it to be worldwide, well, most of the world uses SI units, and so you'd have to add the ability to convert between the two. So if you had a website for cooking that you wanted people to use all over the world, you'd have to have these types of conversions in it. So you would use this library. Let's save that. So now that we have our example then, we've done the first one. The next one I would do is Celsius to Fahrenheit. Okay. So what would I do to do that? Well, I would first figure out what the right equation is, but then add another method, another static method that goes the other way. So, I'll let you do that. As you add a method, it'd be good to go in here in your tester class and maybe copy this for each set. It's going to get a little busy. You don't need to copy the scanner. We already have our scanner, so you can delete that. But here you change this to C temp, get the next value, this to F temp, and pass in C temp. Change our method C to F maybe. It tells you, hey, there is no C to F. And this would be if you want to group them a little bit more, you can put a little bit more space in here. Usually what I do is I put in a blank line, so you have a set of 3 lines like this for each conversion method. Okay? So in here, then you add the other methods. Okay? Is that clear what we're doing? Again, we're trying to create a useful class to help us do conversions between Fahrenheit and Celsius. We'll have an assignment coming up where we need to do this. So again, don't put the main method in here. Put it in here in our tester class, this one. Okay, so you'll have to go online and figure out what the conversion factors are. It'd be nice if you just do the math, but a lot of the times online, they just have a factor. They've already done all the math, and they just give you a factor. Multiply it times this factor, and you'll get the other one. You can do it that way, but if you have a nice equation, you might use the equation just to make it a little bit more understandable instead of just multiplying by a factor. Okay.